At time t is greater than or equal to 0, a particle moving along a curve in the xy plane has position x of t and y of t. So its x coordinate is given by the parametric function x of t and y coordinate by the parametric function y of t. With velocity vector v of t is equal to, and the x component of the velocity vector is cosine of t squared, and the y component of the velocity vector is e to the 0.5 t. At t equals 1, the particle is at the point 3, 5. Is at the point 3, 5. All right. Find the x-coordinate of the position of the particle at time t is equal to 2. All right, so how do we think about this? Well, you could view the x-coordinate at time t equals 2. So let's say, we could say x at time 2, which they don't give it. They don't give that to us directly, but we could say that's going to be x of 1 plus some change in x as we go from t equals 1 to t equals 2. But what is this going to be? Well, we know what the velocity is. And so the velocity, especially the x component, we can really focus on the x component for this first part because we only want to know the x coordinate of the position of the particle. Well, we know the x component of velocity is a function of t is cosine of t squared. And if you take your velocity in a certain dimension and then multiply it times a very small change in time, dt, this would give you your very small change in x. If you multiply velocity times change in time, it'll give you a displacement. But what we can do is we can sum up all of the changes in time from t equals 1 to t equals 2. Remember, this is the change in x from t equals 1 to t is equal to 2. So what we have right over here, we can say that x of 2, which is what we're trying to solve, is going to be x of 1, and they give that at time equals 1. The particle is at the point 3, 5. Its x coordinate is 3. So this right over here is 3. And then our change in x from t equals 1 to t equals 2 is going to be this integral. The integral from t equals 1 to t equals 2 of cosine of t squared dt. And just to make sure we understand what's going on here, remember, how much are we moving over a very small dt? Well, you take your velocity in that dimension times dt. It'll give you your displacement in that dimension, and then we sum them all up from t equals 1 to t equals 2. And in this part of the AP test, we are allowed to use calculators, and so let's use one. All right. So there's my calculator, and I can evaluate. So let's see, I want to evaluate 3 plus the definite integral. I click on Math, and then I can scroll down to Function Integral, right there. The definite integral of, and I make sure I'm in radian mode, that's what you should assume. So cosine, unless they tell you otherwise, cosine of t squared. Now I'll use x as my variable of integration. So I'll say cosine of x squared. And then my variable of integration is x. So I'm really integrating cosine of x squared dx, but it'll give the same value, comma, from 1 until 2. And now I'll let the calculator munch on it a little bit, and I get approximately 2.557. So this is approximately 2.557. Let me make sure that I added the 3. Yeah, 3 plus that definite integral from 1 to 2, 2.557, and I just rounded that. So there you go.